In this video, we will talk about what U-substitution is. So I want to motivate this with an example. Let's say that we wanted to evaluate the integral of x over the square root of 1 plus 4x squared dx. So with this integral, we don't know how to do this, how to evaluate this integral using our current knowledge, of antiderivatives. At least we could try to sort of guess what the antiderivative is and check that it's right by taking the derivative of it and seeing if we get x over the square root. But we'd like a more systematic way of doing this, of finding out what this antiderivative is. Okay, so I'm going to talk about the idea here, but we will make this more rigorous towards the end of the video and as we look at some more examples in the next video. So my idea is I'm going to do a substitution, and I'm going to call the new variable u. I'll let u be equal to 1 plus 4x squared. And I'll talk more about why I'm doing this towards the end of the video and again in the next video about why this is a good choice. So then what I'm going to do is take the derivative. So the derivative would give me du dx. The derivative of 1 plus 4x squared is 8x. Okay, so next, with the du dx, we are going to treat this as a fraction, even though it's not. Even though it's technically not a fraction. Du dx is technically just notational. Okay, so if I were to treat it as a fraction and isolate the du, we'd get du on one side, and then 8x dx on the other side. Okay, so next I am going to isolate dx. And the reason why I'm going to isolate dx is, if I look at my original integral, I see a dx in here. I'm going to use the isolated version of dx to substitute into this integral. And in the same way, because I've let u be equal to 1 plus 4x squared, I'm going to substitute that into my integral. So I'll end up with square root of u on the bottom. Okay, let's isolate that dx first. So we'll get du over 8x equals dx. Okay, so now we are going to substitute. So let's substitute. So if we substitute, we get our integral equals. So we still have that x on the top. Not totally sure what to do with that just yet. And on the bottom, we'll have the square root of u. And then dx, well, we know what dx is. So let me just highlight some stuff. So the 1 plus 4x squared, that's what we said was u. And then the dx, well, we said dx is du over 8x. So let's plug that in. So dx is du over 8x. And now something nice is going to happen because the x on the top and on the bottom are going to cancel. All right, so canceling them, we will end up with an integral. I can move that 8 out in front because it's a constant. So I get 1/8. And then I'll have 1 over square root of u, which I can rewrite as u to the negative 1/2 power, because that's going to make it easier to integrate. And then I still have that du. So what we've done by doing this substitution is we've converted the integral, which was originally in terms of the variable x. There was x's here, and there was a dx term, to be completely in terms of a new variable, u. I have u's in my function, and I have a du instead of a dx. And moreover, the integral that I now have is a whole lot easier to evaluate. And that was our goal from this substitution, to come up with an easier integral. Okay, so one thing I want to note here is once the integral is purely in terms of u, we can integrate. So at this point, there are no x's at all. I've gotten rid of the x's, I've gotten rid of the dx. It's all in terms of u, so I can take the antiderivative. So doing that, we get that 1/8 in front. And then reverse power rule says add 1 to the exponent. So 1 added to -1/2 would be +1/2. And then I divide by that new power. I divide by 1/2. But dividing by 1/2 is the same thing as multiplying by the reciprocal, which is 2. Okay, so that is our antiderivative. But this is an indefinite integral, which means general antiderivative. So I can't forget that plus c. That is very important. Okay, so now we aren't done because the original problem had x as the variable. And I have u in my answer. So we need to substitute back. So now let's substitute back. So if we substitute back, then I can also simplify. 1/8 times 2 is 1/4. So we get 1/4, and then we'll have something to the 1/2 power. What was u? Well, u was 1 plus 4x squared. Let's plug that in. Let's plug that back in. So 1 plus 4x squared to that 1/2 power, and then plus c. And that is our answer. That is our antiderivative. Okay, so let's check that this is correct by taking its derivative. So let's check the answer by differentiating, by taking the derivative. So I should be able to take the derivative of my answer and get the function that was in the integral. So if I were to do the derivative of 1/4 times 1 plus 4x squared to the 1/2 plus c, if I were to take the derivative of that whole thing, let's check that we get the correct value. So to take the derivative of this first part here, this 1/4 times this thing to the 1/2 power, we would need to use the chain rule. And so using the chain rule, we end up with, so that 1/4 stays there, it's that constant in front. And then I deal with the outside part first. So the outside part is the power, this 1/2 power. That comes down, multiplies what I have, and then I get that whole thing, and then I subtract 1 from the power, so I get a -1/2 up there. And then when we do this, we keep the inside the same. So you keep the inside as 1 plus 4x squared. And now to finish off the chain rule, I have to multiply this by the derivative of the inside. So here's the inside, 1 plus 4x squared. The derivative of that would be 8x. And that completes our chain rule. And then we still have this plus c. The derivative of a constant would be 0. So I have this whole thing plus 0. Okay, now we can simplify a little bit. So 4 times 2 would become 8, and that 8 is going to cancel with this 8, so those would cancel. And so the x that's next to the 8 would still be there. And if I bring this 1 plus 4x squared to the -1/2 term to the denominator, it makes the exponent positive. And then the positive 1/2, that's a square root. So I'd get square root of 1 plus 4x squared. So if we look back to our integral that we started the problem off with, that was the function that we had inside of our integral. And that's what should happen here. So we have checked that our answer that we got is correct. Okay, so let me put a check mark next to this. This works. Alrighty, so there's two things that I want to note about this. So the first is this method has a name. So this method is called U-Substitution. We're substituting, and the convention is to call that new variable that we substitute u. So it's called U-Substitution. And the second note is that U-Substitution is actually the chain rule, which is for derivatives, the chain rule in reverse. And we saw that sort of happening when we checked our answer by doing the derivative. We noticed that chain rule was showing up. Okay, so I'm going to use that idea that U-substitution, this method that we just used, is the chain rule in reverse to get the general formula for U-substitution. So recall that when we do the chain rule, if I take the derivative of a composition of functions, let me just write it like this: derivative of f of g of x. Chain rule says take the derivative of the outside, f prime, keep the inside the same, g of x, but then multiply by the derivative of the inside. So multiply by g prime of x. So on the flip side, doing antiderivatives, this means the antiderivative of f prime of g of x times g prime of x. I have to write my dx, that's my notational thing that I put in the integral. This antiderivative, we know, would be the original function. The original function over here plus a constant. So it would be f of g of x plus c. So what I'm going to do now is I'm going to substitute into this. I'm going to let u be g of x. So where the g of x is, I'm going to call this thing u. I'm going to call this thing u. All right, so I'm just moving up to the top of the page to give myself some more room to write. So let's let u be equal to g of x. And if we do that, what we get is on one side we have the integral of f prime of g of x times g prime of x dx. And the antiderivative of that is going to be f of g of x and then plus c. But now, where the g of x is, in the parentheses here, I'm going to plug in u. So we'll end up with f of u plus c. Another way that I could have thought about getting f of u plus c is, this is just the integral of the derivative of f of u du. If I were to take the integral of f prime of u, that would be the original function, but in terms of the variable u. So that would be f of u plus c. So we've just described f of u plus c in two different ways. We've described it in terms of the original integral, this chain rule derivative, and I've also described it in this other way where I made the substitution. Okay, so if we match up corresponding things in these two integrals, so this g of x was the same thing as u. That was our substitution. We let u be equal to g of x. So because these integrals are the same, that would mean that the du has to match up with this stuff. The du has to match up with g prime of x dx. So if we look back to the example that we just did, let's just verify that that's true, that du was equal to g prime of x dx. Okay, so here was the example that we were looking at. And what u is set equal to, this is our function g of x. And if I look at our equation for du, this 8x was g prime of x. So we do have that du equals g prime of x dx, like we were observing in the general formula. Okay, so one of the things that U-substitution essentially says is, sorry, a little bit too far. Okay, here we go. So we had u equal to g of x, and we had that du equals g prime of x dx. One of the things that it says is when we look at the equation du equals g prime of x dx, is we can essentially treat that du dx term as a fraction. So this is the same thing as writing du over dx equals g prime of x. Okay, so more formally, we get the following theorem, which we've essentially just shown. If we have u be equal to g of x, and this is a differentiable function, and its range, the range of this function, is an interval I, and f prime is continuous on that interval I, then the integral of f prime of g of x times g prime of x dx is going to be the same thing as the integral of f prime of u du. That's what we just showed above this. Those two integrals are the same. So our goal when we do U-substitution questions is going to be to convert an integral that looks like this into the form where I have the integral of f prime of u du. Get it purely in terms of the variable u, because this integral will be easier to integrate. This will be easier to take the antiderivative of. So in the next video, we will look at several examples, getting more practice with U-substitution. And one of the big overarching questions that we're going to look at is, when we see an integral, how do we recognize that it has this form in the first place, and then how do we pick what to let u be? In terms of our goals for this section, we have finished our first goal. We've introduced what U-substitution is. In the next video, we will look at some more examples.